Hey, welcome back, class. This is week five's video, and we are going to be testing this week. Now, my A-Day students, your test is going to be on Tuesday, and my B-Day students, your test will be on Friday. What we'll do on Monday and Thursday is we're going to review basically the same material just to make sure you're on the right track, and if there's anything that you're confused on, I can help you. Now, this video is going to be a little bit longer than usual just because I'm going over everything we've learned so far in topic 3, just so that I can make sure if there's something in particular you're confused on, you don't have to watch the whole video. You can just skip to the parts that you might need a quick refresher on. All right, so I'll leave those timestamps below the video just so that you can easily skip to the parts that you might need the most. So, without further ado, let's hop into our lesson. So to start off with, the first thing we learned in topic 3 was exponents, and you all did fantastic with that. So I don't think I have to spend too much time on this material, but just for a quick refresher, exponents are just repeated multiplication, right? You have a base and you have an exponent. The exponent is the little number. So if I had something like this, 5 to the third power, or it's also called 5 cubed, this 5 is my base, so BASE, and this 3 is my exponent, right? So what this is really saying, it's not saying 5 times 3, it's saying multiply your base by itself 3 times. So this should be 5 times 5 times 5, and that equals 125. So on your test, you might see questions that look like this. Write the expression using an exponent. So you have 10 times 10 times 10 times 10. So what's your base? What's the number that you see repeated over and over and over again? 10. So that's your base, and your exponent is however many 10s you see. So 1, 2, 3, 4. So written as an exponent, it should be 10 to the fourth power. And that's it. Now, in order to solve these types of problems, it says evaluate each expression. So what we want to do is look at the base and look at the exponent. 9 to the second power, or 9 squared, means 9 times 9. And then you just have to evaluate or solve it. 9 times 9 is 81. And that's it. Please remember, it's not 9 times 2. If I wanted to say 9 times 2, I would write out 9 times 2. When you use an exponent, it's just the shortcut way of saying 9 times itself however many times. So 9 squared means 9 times 9, which is 81. So over here, we have 99 to the first power. Well, if you're just doing what we've been doing, where it says 5 to the third power means there's 1, 2, 3 5s, and 10 to the fourth power was 1, 2, 3, 4 10s, and 9 to the second power was 2 9s. If you have something raised to the first power, that means it's just 99. It's just whatever your base is written once. So 99 to the first power is 99. Any number raised to the power of 1 is itself. Okay, so it could be 6 million raised to the power of 1, and the answer is just 6 million because I'm just writing that number one time. Now, let's think about this one. 3,105 raised to the power of 0. Anything raised to the power of 0 is what? Any number raised to the power of 0 is 1. Okay? Any number raised to the power of 0 is 1, no matter the number. It could be 1 to the power of 0, and the answer is 1. It could be 16 to the power of 0, and the answer is 1, always. So whenever you see an exponent of 0, the answer is going to be 1. All right, so that's exponents. Let's hop to 3-2 and see if you need any help there. So many of us didn't have too many issues when it came to finding the greatest common factor and the least common multiple. So there's 3 things we actually worked with inside this section. First is that we found the prime factorization. So what we talked about during this week's lesson, the 3-2, Prime factorization is where you take a large number and you break it down into its ingredients, the prime numbers that make up that larger number. So what you want to do is to make a factor tree and basically divide all the way until you get only prime numbers left. So what I would do if I were you is think of a small number like 2 or 3 and figure out, can it go into this number? So 54, 2 times what would give us 54? Well, if you divide 54 by 2, you get 27. Now, 2 is a prime number. And remember, a prime number is what we're looking for. It's a number that can't be broken down anymore because only 1 and itself multiply to give you that. So numbers like 2, 3, 5, 7, those are all prime numbers. So 2 is prime, so I can't get any smaller. But are there numbers that I can multiply to get 27? 3 times 9 gives me 27. Well, 3 is a prime number. Only 1 and 3 go into 3. But 9 can be broken down some more. What number do we know goes into 9? 3. Well, 3 times what? 3. So now what we've done is that we have only prime numbers left. 2, 3, 3, and 3. So we're done. We've done the prime factorization. Now, one way we could write this, when it says find the prime factorization, all you do is you take these numbers, these prime numbers, and you write them out like this. 2 times 3 times 3 times 3. So that's the prime factorization. 2 times 3 times 3 times 3. Now there is another way, a shortcut way, and that's if we use an exponent. See how we have 3 times 3 times 3? So we can shorten this by just saying 2 times 3 to the once, twice, 3, the third power. So either one of these is fine. 2 times 3 times 3 times 3, or 2 times 3 to the third power. They're the same thing. So that's prime factorization. We took 54 and we broke it down to its smallest form, its ingredients, using only prime numbers. Now let's see if we can find the greatest common factor. When we learned this, I showed you 2 different methods. We could do the factor tree method, or what I think is easier is the ladder method. And the reason I choose the ladder method is because it can give you the greatest common factor and the least common multiple by doing the exact same steps. So the way we do the ladder method is you draw a little ladder rung, or a U, around 18 and 32. And what we want to do is find a number that evenly divides into both 18 and 32. Because with the greatest common factor, we want to find what's the biggest number that 18 and 32 have in common that can divide into both. So 18 and 32. What I would do is, if you can't think of a number off the top of your head, start small. Use numbers like 2 and 3. Since they're both even numbers, I know 2 can go into both. 2 times 9 gives us 18. And 2 times 16 gives us 32. Now what we want to do is keep doing this until there isn't a number that goes into both of these. Well, 9 and 16. Is there any number that we know that goes into both 9 and 16? Well, for 9, we know 3 goes into it, right? Because 3, 6, 9. So 3 goes into 9, but does 3 go into 16? 3, 6, 9, 12, 15, 18. No, so 3 is not a factor of 16. 2 is a factor of 16, but 2 is not a factor of 9. So that means that the only number that goes into both would be 1. So we're done. We can't get any smaller than a 9 and a 16. So the greatest common factor, what you do once you've reached this step where you can't go any farther, is you look at the numbers that are on the left. In this case, it's only 2. So that's your greatest common factor. Your GCF here is just 2. If there were other numbers over here, you would just multiply the numbers on the left. That's it. But in this case, it's just 2. Now let's find the least common multiple. So similar to the greatest common factor, but the least common multiple is the smallest number, so least, smallest number they have in common that they both multiple, up to. So we want to figure out what's the smallest number or the first number that they have that 40 and 60 have in common that they both can multiply up to. And we can use the exact same method. Let's think of a number that goes into both 40 and 60. Well, they're both multiples of, or 10 can go into both, right? 10 can go into 40 4 times, and 10 can go into 60 6 times. Is there a number that goes into both 4 and 6? 2. Can't 2 go into 4 and 6? 2 times 2 gives you 4, and 2 times 3 gives you 6. Well, 2 and 3 are both prime numbers like we found out over here, so this is the smallest you can get. Now, the difference between the greatest common factor and the least common multiple using the ladder method, the GCF, the greatest common factor, you only multiply the left numbers. The LCM, what you do is you multiply all of the numbers on the outside. So you draw a big L and you multiply all of the numbers out here. So 10 times 2 is 20. 20 times 2 is 40. 40 times 3 is 120. So the least common multiple, this first smallest number that both 40 and 60 multiply up to, is 120. That is your LCM. Okay, that's it. That's all there is for 3-2. Finding the prime factorization, GCF, and the least common multiple. All right, let's move to 3-3. I think hopefully a lot of you guys enjoyed 3-3 because all this one was finding the order of operations. And that's where you use please excuse my dear Aunt Sally in order to solve these types of expressions, right? So we just want to do it one step at a time. So looking at this expression right here, we see brackets, we see parentheses, multiplication, exponents, division, addition, there's fractions, right? We want to break this down one step at a time. First up is parentheses. That's the first thing that you do in order of operation problems. Sometimes you might hear me say, instead of parentheses, let me choose a darker color. You might hear me say a G for grouping symbols. And the reason I want you to get in the habit of that is that it's not just parentheses. It can be brackets, absolute value bars, anything that's grouping something together. That is what you would do in this step. And if you notice, you see parentheses and brackets in here. Just think of brackets as outside parentheses. So look inside the brackets and chances are you'll find parentheses in there. Start with those inside parentheses. So let's look in here. Now inside of these parentheses, we have an exponent and multiplication. But looking at the order, which one do you do first? Exponents or multiplication? Well, exponents comes first, so we want to do that first. So 10 to the power of 0 is 1. So remember, anything to the power of 0 is going to be 1. What I want you guys to get in the habit of doing, because on the test I'm not going to give you a calculator, I want you to take these one step at a time. So once you solve this step, bring everything else down. So 2 times 1 bracket divided by a third bracket plus 8. So looking at this new blue step, let me change colors. Do we still have parentheses or grouping symbols? Yes, we have all of this still. So let's finish this inside parentheses. 2 times 1 is just 2. So we have 2 divided by 1/3, and this is all in brackets still, plus 8. So if you notice, our answers or our problem is getting smaller and smaller as we get closer to our answer. And that's what we want. We want our final answer to be basically like an upside down triangle, just working our way smaller and smaller and smaller till we get to our final answer. All right, so let's try the next step. Do we still have parentheses or grouping symbols? Yes. Now inside of this bracket, these grouping symbols, there's only one thing to do, which is to divide 2 divided by 1/3. Now remember, when dividing by a fraction, here's a tip. Keep, change, flip. Or you can divide by finding a common denominator. But I'm just going to do the keep, change, flip. Keep 2 the same. So I'm just going to write 2 over 1. Change division to multiplication. And the reciprocal of 1/3 is 3 over 1. And then multiplying fractions just straight across. 2 times 3 is 6. 1 times 1 is 1. So my answer here is just 6. And bring down the last step, plus 8. Do we have any more exponents inside this red step? Nope. Multiplication or division? Nope. Addition or subtraction? Yes. 8 plus 6 gives us 14. And there's your answer. So we worked from this whole problem smaller and smaller and smaller until we got just 14. And that's it. So just make sure you follow these steps when you're solving numerical expressions. Order of operations, always, always, always. And just do it one step at a time. It's when you do try to do more than one step at a time that mistakes are made. So just take it one step at a time. You'll be fine. Okay? All right, let's move to 3-4. Now, 3-4 and 3-5 dealt with algebraic expressions for the first time. And that's where we had to take a sentence and write out an algebraic expression, or we had to solve an algebraic expression where I give you the answer or I give you the value of a letter, a variable, to plug into an expression, and you just had to solve it. So let's first start with writing an algebraic expression. So this stuff over here. It says write the algebraic expression to represent the situation. Now, what we worked on with these types of problems is that we want to pull out the important information first. So what I would do is underline, circle, whatever you might need to do in order to see what is important. That way you can break down piece by piece by piece. So 22, less than 5 times a number f. So let's break this down piece by piece. We have 22 less than 5 times a number f. So that means that less than means subtraction, right? We should have 22 less than a certain amount. Well, what's the amount that we're taking 22 from? 5 times a number f. So 5 times a number f. That's it. All we're doing is we're taking the important information and just bringing it down. 5 times a number f, and I could have written it with a multiplication symbol in between, and that's fine. But then we want to subtract 22 from it. And this is all you have to do. We're not solving anything. We're just writing algebraic expressions. Let's try the next one. 3 times the sum of m and 7. So 3 times the sum of m and 7. Well, sum is the answer to what type of operation? Sum. Difference is subtraction. Product is multiplication. Quotient is division. And sum is the answer to a addition problem. Well, what are we trying to add here? We're trying to add m and 7. Right? So that's a given. We want to figure out what's m plus 7. What I'm going to do, since I know that we're going to be multiplying 3 times this amount, I'm going to group these together because now we're going to do 3 times this amount. So I could have 3 times this amount. And that's it. Just take it one step at a time. So that's one part. Now, 3.5 is dealing with evaluating algebraic expressions, which I think all of you are going to be doing just fine on. It's just where I give you an amount to plug in to the variable, and then you just solve it. It turns into an order of operations problem after that. So the only tricky part is putting in the number or substituting in the number for the variable. That's it. So looking at number 3, it says evaluate the expression when x equals 4. So we want to take x and substitute it in to our problem. So 12x minus 7, x comes out, 4 goes in. Now, before we do that, what's going on between this 12 and this x? Please remember it's multiplication. Even though there is no operation symbol there, it's implied in algebra that if there isn't an operation shown, it's for you to assume that it's going to be multiplication. So 12 times x, and x is 4. So I could rewrite this 12 times 4 minus 7. And now it's just an order of operations problem. There's no parentheses. There's no exponents. There is multiplication or division. So we want to start with this 12 times 4, which is 48. And then we just bring down, I'm going to draw it over here because I don't have much space. Then I just bring down that minus 7. 48 minus 7 is 41. And there's your answer. That's it. So all we're doing here is you take the value that I give you for the variable, plug it in, and just solve it. Let's look at the second one. Evaluate the expression when x equals 4 and y equals 8. So what we want to do is substitute in 4 for x and 8 for y, and then just solve the problem. So if I were to do 4 in for x, x comes out, 4 goes in. Now it's 4 squared divided by, let me choose, divided by y. Y is now 8 because I'm going to substitute in 8. That's too light. Let's try green. So y came out, 8 went in. Here's my new problem. 4 squared divided by 8. Do we have any parentheses? Nope. Do we have any exponents? Yes. So 4 squared doesn't mean 4 times 2. It's 4 times 4, which is 16, divided by 8. Well, 16 divided by 8 is just 2. And there's your answer. 2. That's it. So for 3-5, all you have to do is take the number that I give you for the variable, plug it in, and just solve. Okay? That's 3-4 and 3-5. Let's hop to 3-6 now. Now I grouped 3-6 and 3-7 together last week. We did those at the same time. I'll break it down one and the other for review's sake, just so that we can talk about it. Maybe you understand 3-7 a little bit better, and 3-6 is a little bit more complicated. So 3-6 dealt with equivalent expressions. And remember, equivalent means the same, right? Equivalent means that they are the same. The key word there is equa, which means equal, right? So we want to find an expression that is equal to another expression, 2 expressions that are the same thing. So there's 2 ways that we can do that. We can use the distributive property, or we can do factoring. Factoring is, in other words, the undistributive property. It's the opposite. So the distributive property says that you can distribute a number to everything inside of the parentheses using multiplication, and you get the same answer. So right here it says, are the expressions 5x plus 20 and 5 parentheses x plus 4 equivalent? So it's asking, is this expression the same as this expression? What we want to do is, since we see that there's a number outside of these parentheses, we can use the distributive property to rearrange the expression and see, does it match the other one? All right, so let's do that. If I have 5x plus 4 and we use the distributive property, it says that since you have a number outside of the parentheses, this 5 is outside of the parentheses, it's technically being multiplied to everything on the inside. That's what the distributive property says, and it's true because I can take this 5, multiply it by this x, and take this 5 and multiply it by the 4, and it rearranges the expression, but it's the same thing. 5 times x, right? 5 times x, when you multiply them together, since we don't have a value for x, just means that it's 5x. Because whenever you have a number next to a variable, that's multiplication. So 5 times x is just 5x. Now, there's a plus sign here, so we'll bring down the plus sign. 5 times 4 gives you 20. So what we just did is we distributed the 5 to everything inside of the parentheses, and we got this new expression that is 5x plus 20. Now the question was asking us, is or are the expressions 5x plus 20 and this expression the same thing? Well, once we used the distributive property, we saw that this expression is equivalent to this expression, which is 5x plus 20. So the question is really asking you, is 5x plus 20 the same thing as 5x plus 20? Yes, it is. So are they equivalent? Yes, because they're the exact same thing. Now looking over here, we can do the opposite of the distributive property. If we used multiplication here for the distributive property, in order to get this expression, if we did multiplication, what's the opposite of multiplication? Division. So that means that we can use division on this expression to work backwards to find an equivalent expression. It says make an expression equivalent to 5x minus 55. So what we want to do is we want to use division to work backwards to make an equivalent expression. So our final answer, our equivalent expression, should be in the format of what we had here, where you have a number outside of parentheses, and we just want to fill in these blanks, right? I have a minus sign, an x, an x. So I'm set up. I just need to figure out what numbers go in those blanks. So looking at 5 and 55, what is a number that we know can divide into both 5 and 55? Well, what number do we see written 3 times here? 5. 5 goes into 5, and 5 goes into 55. Well, how many times? 5 times 1 gives us 5, and 5 times 11 gives us 55. And this is our answer. This expression that we just made is equivalent to this expression because they're the same thing. Now we can test it just to make sure we are correct. Using the distributive property, let's see if we can work back to get this expression. What's 5 times 1? 5 x minus, so I'm just bringing down that x and the minus sign. What's 5 times 11? 55. And isn't that the expression that we started with? Yes, so we are correct. So this right here is the equivalent expression to this right here. Okay, factoring is working backwards using division. The distributive property means that you're distributing a number inside of the parentheses using multiplication. Okay? All right, let's try 3/7 now. So what 3/7 is working with is basically just simplifying an algebraic expression, making an expression more simple to work with. We're not solving anything, right? We're not solving anything, but what we are doing is we're trying to see, can we take an expression, combine anything that looks similar to make the expression smaller and easier to work with. So let's look at the first one. It says 9y plus 4 minus 6y. Let's break it down into terms and that may help us visualize this a little bit better. So my terms are separated by plus and minus signs. So that means that I have a 9y plus 4 minus 6y. Is there anything that sounds similar in this expression? Something that we can combine? Well, we have two terms that have a variable of y. So we have a 9y and a 6y. So we can combine those since they are like terms. 9y minus 6y. So we always look at the operation symbol that's in front of my term. So 9y minus 6y. If I had 9 yellow bananas and I take away 6 yellow bananas, how many am I left with? 3 yellow bananas. So we just combined 9y minus 6y to make my expression more similar, to make it more easier to work with. Now let's look over here. Is there anything similar to this plus 4? Are there any more constants? No. Plus 4 is by itself. It's the only constant in my expression. So since there's nothing I can combine with it, I just bring it down. Nothing changed with it. So now we're left with a 3y plus 4. That's the simplest we can get. We can't combine 3y and 4 because that 3 and that y are combined together, right? We can only combine like terms. And since this 3y is a term and this 4 is a term, there's nothing similar about it, okay? Let's look at this next one. It says 16n squared plus 4.5 minus 2n squared plus 0.5 minus 3.9. So same thing. Let's separate our terms so we can get a better idea of what we're looking at. So we have a plus sign, a minus sign, another plus sign, and another minus sign. So that means that our terms are 16n squared, 4.5, 2n squared, 0.5, and 3n. Those are the terms we're working with. Are there any terms that look similar? There's a couple, right? We have a 16n squared, and are there any more n squareds terms that have n squared in it? Not 4.5. But here's an n squared, 2n squared. So we can combine this 16n squared with this 2n squared because they are like terms. They have an n squared in common. So 16n squared minus 2n squared. 16 minus 2 is 14n squared. Now that we're done working with those n squareds, I'm just going to cross them out just so I know not to work with them anymore. We have a constant of 4.5. Are there any more constants? Yes. There's a 0.5 over here, so I can combine these two terms because they are both constants. They don't have variables, they're just regular numbers. And we know we can combine regular numbers. We've been doing it since you were in kindergarten up until now, right? 4.5 plus 0.5. If you think about it in terms of money, if I have $4.50 plus 50 cents, how much money do you have? $5. So this is a plus 5. Well, we're done with this constant, done with this constant. What's left? There's a 3n over here. Now, there are no other terms that have just a regular n in it. So that means that it's just going to stay a minus 3n. There's nothing I can do with that. So our simplified expression here is 14n squared plus 5 minus 3n. Now on the test, just so you know, you might see that these numbers are rearranged. And the reason that we do that is just so that you keep your expression looking clean and neat. It's kind of like this is a number sentence, and we just want to make sure things are in the correct order. So the other way you might see this written is 14n squared minus 3n, so putting the things that have variables together, and then just having your constant off to the side, so plus 5. All we did is we took this and just switched them. So just so you know, either answer is fine, but technically this one's the more mathematically correct right? Because it's written in the correct order. You always want to have your variables come first and then your constants are last. But either answer is fine. So that's all I have for you. That's just the review. Hopefully that helped a little bit just to be able to see what we worked on so far with topic 3. Hopefully it helped. Like I said, our test is going to be on Tuesday for my A-Day students and Friday for my B-Day students. Hopefully we have a full week this week. There is some snow that's coming in, but we'll take it as it comes. If it does knock us back, then we'll still review. Depending on what day is called off, we'll just do what we can. So we'll be flexible, just like we always are, and we'll work with what we're given. But please take your time. This test is probably going to be one of the bigger grades for this 9 weeks. We're already about more than halfway through this 9 weeks. So just take your time, try your hardest, and I'm sure everybody's going to do fantastic. If you have any questions, please make sure you reach out, ask the questions in class, and I can always help you as well. I have office hours, of course, on Wednesday. So if you have any questions then, I can help you then. Just please, I don't know if you're having any issues or struggling unless you tell me. Okay, I'm here to help, and I'll make sure I get you on the right track. So, as always, I hope to hear from all of you soon. Send me a message on Schoology if you have any questions. And until next time, I'll see you all in class, or I'll see you in the next video. Bye, everyone.